The spectrophotometric determination of an equilibrium constant. Here is the equilibrium reaction that we are working with. It is iron 3+ with thiocyanate combining to form an iron thiocyanate complex. And the equilibrium constant expression is the product concentration over the two reactant concentrations. So in this experiment, we are trying to determine that value of K. And the way we are going to do it is by following the concentration of iron thiocyanate through absorbance. This happens to be a colored compound. It's a red or dark wine color, and it has a measurable absorbance. All right, so we need ways to determine the actual equilibrium concentrations of these substances. We will use a way to measure the iron thiocyanate and then backtrack stoichiometrically to get the other two equilibrium concentrations. All right, in part 1, we are going to establish the calibration curve for the iron thiocyanate. We are going to do that by forcing this reaction to completion rather than an equilibrium. We're going to do that by adding a huge excess of one of the reagents. So in part 1, you're using concentrations that are 0.200 molar for the iron and 0.0002 molar for the thiocyanate. So you can see the huge difference there. The iron is in an excess, and in so much excess that we can assume that all thiocyanate is consumed and used to produce the product. All right, so you're going to have 4 standards. You're going to vary the concentrations, measure the absorbance to create the calibration curve. So for standard A, you're going to add 5 mils of the iron, 2 mils of the thiocyanate, and you will also have to add some nitric acid to balance the volume and keep it in acidic solution. There's 8 mils of that. And your total volume for standard A is therefore 15 milliliters. Once you mix all of those by carefully measuring each amount and placing it in a beaker and allowing it to mix, you'll see the colored compound form, and you can measure the absorbance for standard A. And you can do standard B, C, and D. Now, how to get the actual concentration? This is an excess, so that doesn't matter. These two concentrations have been diluted because you added them in with a bunch of other solutions. So you need to use M1 V1 equals M2 V2 to determine the concentration of what we will call the limiting reagent. All right, so 0.0002 molar times 2 milliliters will give us our new concentration, and our total volume is 15. So when you solve for this new concentration, you get 2.667 times 10 to the negative 5. This is a 1-to-1 ratio, so however much thiocyanate you added, that is how much iron thiocyanate is produced. So the concentration here would be 2.667 times 10 to the negative 5. Once you do this for all 4 of the solutions where this number varies, you can create your calibration curve by graphing absorbance versus concentration of the iron thiocyanate. And hopefully it is seen to be a linear relationship where you will determine the equation of the line. Now, if I go ahead and plug in what x and y are, it's an equation that will look like this. Absorbance equals whatever the slope is times the concentration of the iron thiocyanate plus whatever the y-intercept is. All right, now that we have established the relationship between the absorbance and concentration of iron thiocyanate, we can run an experiment and measure the absorbances of our experimental solutions and be able to calculate the concentration of iron thiocyanate. All right, so in part 2, we're going to run the reaction in such a way that it goes to equilibrium. So, the concentrations are different. We're going to start with 0.002 molar of the iron and 0.002 molar of the thiocyanate. So now there will not be an excess. For our solution 1, we are going to use 5 milliliters of the iron and 1 milliliter of the thiocyanate, and the nitric acid will be 4 milliliters, and the total volume is 10 milliliters. And we are starting with 0 iron thiocyanate. So we're going to set this up like an ice table in order to help us understand what's going on. So in order to get our initial concentrations, we have to look at the dilution of all of the solutions here. So we have the iron is diluted. We need to use M1V1 equals M2V2 with the total, and the same thing for the thiocyanate. So 0.002 molar times the 5 mils will give us our diluted concentration when diluting to 10 mils. And that is 0.001. And for this one, if we do this 0.002 molar times 1 mil, we get the diluted volume when diluting to 10 total milliliters, which is 0.0002. So when we set this ice table up, our initial is 0.001, 0.0002, and we have 0 of the iron thiocyanate. It has to move in the forward direction because we have 0 of the iron thiocyanate. So minus x plus x. So at equilibrium, we have these expressions, 0.001 minus x, 0.0002 minus x, and x. Only in class, we typically take these and plug them into an expression for k and use the value of k to solve for x. Today, we're trying to find the value of k. So here is where the experiment comes in. You are going to measure the absorbance of the final solution. And you're going to use that absorbance to determine this concentration. All right, so you can take the absorbance, plug it in, solve for your iron thiocyanate concentration, and that is your x. Once you have that concentration, you can then plug it in here and get this equilibrium concentration, plug the x in here, and then get this equilibrium concentration. And now you can take all 3 equilibrium concentrations, plug them in here, and you get your first value of k. The experiment is repeated for solution 2. You can get another value of k, and solution 3, 4, and 5, And then you can take the average, the standard deviation, and use the value reported in the lab manual to calculate the percent error. I highly recommend trying to use Excel for these calculations because it will prevent rounding and the calculations are extremely repetitive.